right, it is time for your Chapter 8 practice test. So let's review what is going to be on your actual test. Number 1, you're going to have to write the polynomial in standard form. Standard form again means the biggest exponent comes first, so that's going to be my 5x cubed. The next biggest would be the negative 3x squared. Then you have the plus 2x, and finally the plus 6. This is correct standard form. Number 2, standard form, the largest exponent is to the 5th power, so my term that's 8x to the 5th needs to come first. Then my plus 2x squared. Then my plus 9x. And last, my plus 7. All right. Then we start with addition. So when it says simplify and you have an addition in between these polynomials, all you're going to do is combine like terms. So you have a 4x squared plus a 2x squared. 4 plus 2 is 6. Excuse me. 6x squared. Remember, you're not changing the exponent unless you're multiplying. When you're adding, you're just combining like terms, which is just the coefficient, which is just the number in front. The x squared is kind of just like its label, so you just stick the label with it. Next, we have 9x plus 7x, which is plus 16x. And then you've got 1 plus 13, which is positive 14. All right, the tricky ones are subtracting. And so here we go. When you subtract, you have to actually distribute that hidden invisible negative 1 to each of these terms in my second set of parentheses. So instead of 5r squared, I want to look at that as negative 5r squared. Instead of 8r, it's negative 8r. And instead of negative 6, it now becomes negative times negative positive 6. And then I'm going to scratch this out. You don't have to, but to me, it is so much more confusing to see it twice. I'm more likely to make a mistake. So now that we have gotten rid of all this, you can just combine like terms, which is basically adding, just like we did on number 3. So I'm looking for a like term with 8r squared. So 8r squared and minus 5r squared, or negative 5r squared. 8 minus 5 is 3. So we've got 3r squared. Negative 8r and 5r is negative 3r. And then 7 plus 6 is 13. Okay, so again with number 5, you're subtracting. That means you're distributing that negative to all the second set of parentheses. So this is a negative 3y squared. This is now a positive 2y. And this is now a negative 9. So then when you scratch it all out and combine, you're really just adding your like terms. So you've got a 5y to the 4th. I don't actually have any more 5y to the 4th, but it needs to be in standard form, so that is going to come first. 5y to the 4th has the largest exponent, so the highest priority, so we're going to write that first. I don't have any other things that are squared, so that's going to come next. So minus 3y squared. These are like terms. 7y plus 2y is positive 9y, and then plus 2 minus 9 is minus 7. All right, we've got one more that's addition, so we don't have to distribute the negative this time. We're just going to combine those like terms. So negative 7x to the 3rd and 6x to the 3rd would be negative 1, so I'm just going to write it like negative x to the 3rd because there's a hidden 1 there. My next highest priority like term is 10x squared, and there isn't a like term that goes with it. So we're just going to leave it plus 10x squared. The next one is 4x, so it's plus 4x. And then the last one, negative 6 plus 3 is negative 3. Use your calculator if you're not sure. All right, on number 7, you are distributing. So to simplify this product, you're just multiplying and you are distributing. So you've got negative 1p times 8p squared. That would be negative 8p to the 3rd. Again, up here you didn't change the exponent because you were adding. But now that we're multiplying, you do add the exponents. Negative p times 3p is negative 3p squared because there are 2 of them now. All right, when you get to number 8, you can box, you can FOIL, you can distribute, whatever your favorite way of multiplying binomials is. I am probably going to FOIL this. So my firsts are r times r, which is r squared. My outsides are r times 6, r times 6, which is 6r. My insides are 8 times r, which is 8r. And my lasts are 6 times 8, which is 48. And remember that your middle two like terms, your outsides, insides of FOIL, are going to be like terms. So the final answer would be r squared plus 14r plus 48. All right. So I am going to FOIL this one as well. 5w times 2w is 10w squared. My outsides are 5w times 7, which is 35w. My insides are negative 6 times 2w, which is negative 12w. And then my lasts are negative 6 times positive 7, which is negative 42. Oops. There you go. And remember, your two middle terms are like terms, so the final answer would be 10w squared. I don't know what 35 minus 12 is. 35 minus 12 is 23, positive 23w, and then you've got your minus 42. All right, I'm glad I did FOIL on both of those because I am going to box this one. It's a binomial by a trinomial, so I'm going to make a 2 by 3 box. All right, so 3 spaces by 2 spaces. And my 2 are 4s and 5, so 4s and 5. And then my 3 across the top are going to be 7s squared, negative 4s, and positive 3. All right, remember to fill in the box you're multiplying. So 7s squared times 4s is 28s cubed. 4s times negative 4s is negative 16s squared. 4s times 3 is 12s. 5 times 7s squared is 35s squared. 5 times negative 4s is negative 20s, and 5 times 3 is 15. Okay, remember when you do a box, usually your diagonal terms are your like terms, and you're going to be adding your like terms. So I'm going to put a little plus sign in between both of those. All right, so from left to right, the largest priority is my 28s cubed. So the answer is 28s cubed. And then I'm going to go ahead and add these two like terms. So 35 plus negative 16. 35 plus negative 16 is 19. So positive 19s squared. And then you've got negative 20 plus 12. Negative 20 plus 12 is negative 8s. And then you've got your plus 15 down here. Okay, so that was a big one. But at least you can see where all the work comes from whenever you do a box. Okay, number 11, you can totally go ahead and write this out twice. Q minus 1 squared just means Q minus 1 times Q minus 1. So if you are afraid you're going to do the little shortcuts wrong, please just write this out twice and FOIL it or box it or do whatever you like to do when you multiply binomials that usually gets you the right answer. My shortcut is if you square the first term and then multiply these two terms, so q times negative 1 is negative 1q, and then double it, that'd be negative 2q, and then square the last term. So negative 1 times negative 1 is positive 1. That is the shortcut. But if you do not want to do the shortcut or you're afraid because it's a lot in your head, please just write these both out and just FOIL it or box it. Doesn't hurt to do a little extra work just to make sure you're right. Okay, again, the cool thing about this, if you don't want to box or FOIL it, is right away you should recognize that the outsides and the insides are opposites. If I foiled this, my outsides would be 15g and my insides would be negative 15g. And if you think about it, 15g plus negative 15g are opposites. They are going to cancel each other out. So all you have to do in a problem like this is your firsts and then your lasts. So 3g times 3g is 9g squared. And then my lasts, negative 5 times positive 5 is negative 25. So again, if you would rather just go ahead and show your work and box this or foil it, and then combine your like terms, which is going to drop these out, this should still be your final answer. All right, on the back, when you're finding the greatest common factor, you're just deciding what is the biggest number that will go into all three of these and what is the biggest amount of x's that I can also pull out of these. So I think right off the bat, the biggest number we can pull out is 2, because the only factors of 22 are 1 and 22 and 2 and 11. That's the only thing you can divide to get 22. But 2 will also come out of 16 and 30. So I'm going to divide out a 2, and I'm going to divide out the most x's we can pull out are 2 of them. So 2x squared, oh, and that's all we have to do. You're just finding the greatest common factor. You're not actually factoring it, you're just finding what it would be. Okay, 14, once again, we're just finding what it would be. So we're not actually having to factor it, we're just finding what the greatest common factor is. So 7 is prime. The only thing that will divide by 7 is 1 and 7 itself. So nothing will come out as far as a number. But what about the v's? We have 3 here, 2 here, and 4 here. So the greatest amount of v's we can pull out would be 2. So the greatest common factor here is just going to be v squared. Okay, now we have to factor it. So remember that to factor it, you're going to pull out the greatest common factor. These don't have one that we can divide out first. So we are going to do the 2 sets of parentheses, which basically unfoils it. And here's what you know. You know that x squared is going to mean that there's an x at the front of both sets of parentheses. Because they're both addition, these are both also going to be addition. Now, we need to come up with what number when we multiply we get 72. Sorry, what 2 numbers? You multiply to get 72, and you can add to get 17. So what are the factors of 72? Factors of 72, I'm just going to list them off to the side. 1 and 72. I don't know what 72 divides by. Does it divide by 8? 8 and 9. Actually, let's stop right there. 8 and 9 make 17 by adding, right? 8 plus 9 is 17. So I actually guessed it right. So, and maybe you guys had already come up with that. I hope you had. Probably better at numbers in your head than I am. So 8 times 9 is 72, and 8 plus 9 is 17. So our answers are x plus 8, x plus 9. And again, if you want to check it, go ahead and box this or foil it off to the side or on a scrap piece of paper and make sure that your answer comes out to be x squared plus 17x plus 72. But if you factored this right, it would be. All right, number 16. See if we can pull out a greatest common factor first. And no, we cannot, because these are both prime. And we can't just guess and do it kind of like we did this one, because my first term here was 1, and unfortunately my first term here is not 1. So we're going to use the diamond method. So I'm going to choose to use the diamond method. You can guess and check if you want. But the diamond method, again, is at the top, it's your a term times your c term. So 4v squared times 7 is 28v squared. The bottom section of the diamond is your b term, so negative 11v. And then you put your 4v over the top part of a fraction here and here. 4v over, 4v over. And now we come up with what you can multiply to get 28 and what can you add to get negative 11. So you know that if you're multiplying and it ends up being a positive number, and you're adding to get a negative number, that must mean we're going to be dealing with 2 negatives, because a negative times a negative will give us a positive, and a negative plus a negative will give us a greater negative. So I'm going to try to think of the factors of 28. 1 and 28, 2 and 14, 4 and 7. 4 and 7. And if they're both going to be negative, and we know that because a negative times a negative will be a positive, and a negative plus a negative will be a greater negative, -4 plus -7 is -11. So this is it. So we're going to take those two numbers and put them underneath this fraction on the denominator. All right, and then we are done, except for that if you can simplify these fractions, you should. You cannot simplify this one, so it's done. But you can simplify 4 divided by 4. 4 will divide by 4 and go into itself once each time. So our final answer is 1v minus 1 and 4v minus 7. All right. 17, oh good, it is back to where the first term is 1, so we can just do this a little bit quicker in our head without having to use the diamond method. We know in this case that n's are going to be at the front because it's n squared, and we know that they're both going to be minus because a negative times a negative is what's going to give us that positive, while a negative plus a negative is what's going to give us a negative added together. So my factors of 64, 1 and 64, 2 and 32, 3, 4, oh, 8 and 8, right? 8 times 8. So we've got 8 times 8 to be 64, and 8 plus 8 would be, well, -8 plus -8 would be -16. So 8 and 8. And by the way, if you get this as an answer and circle it, it's totally correct and it's fine. But I forgot, this is a perfect square. So I should have just known in my head that this is going to be n minus 8 squared. So again, if you circle this as your final answer, it's correct. I won't count it wrong, but you can shorten it up by doing n minus 8 squared, and I should have recognized that 64 is a perfect square of 8, and you can obviously add -8s to get that. So yeah, I should have known that earlier. That's all right. All right, so here is an example of where our b term dropped out. So if our b term dropped out, that means that we must be adding something and subtracting it in the middle that are both the same number. So here's what we want to do first. We want to factor out the greatest common factor if there is one. And I wonder, I feel like 54 divides by 6. Let's check. 54 divided by 6. It does. It's 9. So we can pull a 6 out. So let's factor out the 6, and it would leave t squared minus, what do we say 54 divided by 6 is? 9 minus 9. And now that my brain is thinking of perfect squares, I recognize that 9 is a perfect square. So 9 is a perfect square with 3's. And I know that in order to have a -9, I'm going to need to have a positive times a negative. And don't forget that 6 is still there. So this is your final answer. We factored out the 6, but it still stays part of the answer. To get t squared minus 9, it would be t plus 3 times t minus 3. All right. Again, I see right away 121 is a perfect square. 11 times 11 is 121. So I know that this is going to be y plus 11 and y minus 11. Because 11 times -11 is -121, y times y is y squared, and that middle term, -11y plus 11y, would have canceled each other out. Okay, here is our latest lesson where you have to factor completely. First thing you want to do is look for a greatest common factor amongst all 4 terms. But I don't see any because I know 7 is prime. So then what you're going to choose to do is you're going to factor by grouping. You're going to group 2 of these together. And I hope you remember from the lesson that you don't have to just group the first 2 and the last 2. I usually do that, but in this case, I don't really want to because, well, okay, I will. It doesn't matter. Doesn't matter, so we might as well stick to it. I was going to rearrange it and put the 7h to the 4th with the 28 because then we could pull out a 7, but whatever. Doesn't matter because we've still got like terms here we can pull out and here that we can pull out too. So first thing you want to do is not look at the second set of parentheses. Only look at this first group. What is the greatest common factor we can pull out of this term and this term? We can pull out h's. as many as 3. So let's pull out h cubed. And that will leave us with 7h and minus 4. Okay, double check that when you distribute, this is what you would have got. Okay, now let's look at just my second group. What is the greatest common factor I can pull out of 28h squared and negative 16h? It would be, I don't think 28, maybe 4? 28 divided by 4, yes, 4. So we want to pull out 4. Oh, and we can also pull out an h from each one. So we're going to pull out 4h. Huh, interesting. Okay, 4h, and it would leave inside the parentheses 7h and minus 4. Okay, let's look. Thank goodness we have the same thing twice. Since we have this same thing twice, we know we did it right. So the thing that is written the same twice is one set of parentheses of your answer, and the other part of your parentheses answer is the greatest common factors that you pulled out from each one. So h to the third and positive 4h. And the order doesn't matter. If you guys put this one first and this one second, it does not matter. All right. 21, once again, I don't see any common factor that we can pull out of all 4. So I would actually first go ahead and group them. So let's group them. All right, what I notice is that I can pull a t squared out of both of these. So t squared. And that is going to leave 15t, oops, I made my little parentheses a little too small, and plus 2. All right, with the second group, remember that if your first term is negative, you have to pull out a negative. If you don't pull out a negative, it is going to be wrong. So let's see what else we can pull out. 45 divides by 3, and I believe that is the biggest number that we can pull out. So 3, and that leaves 15t, because 3 times 15 is 45. Negative 3 times 15 is negative 45t, and negative 3 times positive 2 is negative 6. All right, and we did it right because both of these are the same. So that is one set of binomial part of your answer, and the other one is what's outside, which is t squared and minus 3. All right, let's keep going. We're almost done. Last 3. Factor completely. I see a like term that I can pull out of all 3 because I know that 9, 12, 18, and 24 all divide evenly by 3. So I am going to divide out a 3. Oh, whoops. Sorry, I skipped one, didn't I? Oh, and I was writing 3 on that one. That one won't work. I'm sorry. Let's do 22. And on 22, you can also pull out a 3. Okay, so I should have left that. Anyway, I can also pull out 2 n's. So n squared is going to also be coming out of that one. So 3n squared times 2n squared. 3n squared times 5, just n. And 3n squared times minus 3. Okay. So now we've got a problem. We're not quite done because this can be factored again. So I'm going to leave 3n squared as part of my answer, but I'm not going to put it on there yet. I'm going to go ahead and do diamond method with just this trinomial to try to break it down a little farther. So 2n squared times negative 3 is negative 6n squared. 5n is my b term. 2n over 2n over. All right, so what can we multiply to get negative 6n and add to get positive 5? So if we're multiplying to get a negative, I know it's going to be one of each. So one's going to be positive and one's going to be negative. Let's think of the factors of 6. We have 6 and 1 and 2 and 3. Which one of those can we add to get 5? Well, actually both, because you could subtract these or you could add these. So let's go on one step further. We want to multiply and be negative 6. So that could be this way. 6 times negative 1 is negative 6. What about 6 plus negative 1? Yes, that is 5. Okay, so it's going to be 6 and negative 1. So I'm going to put 6 and negative 1 as my denominators. These won't simplify, so it's done. These will simplify. They both divide evenly by 2. And then it's done. So my final answer, I have to bring down the 3n squared. Don't forget about that guy. And then you have your first set of parentheses, which is n and plus 3. And then you have your second set of parentheses, which is 2n and minus 1. All right, now we're at this one. Okay, remember we already kind of talked about this one. This one you can pull out a 3. We can also pull out a v because all of them have at least the one v here. All right, so the rest is 3v to the third plus 4v squared minus 6, and all I'm doing is reverse distributing to check to get 18. So 6v and then minus 8. Okay, make sure that if you were to distribute this back in, it would end up being this polynomial. All right, next we still have 4 terms and none of them have a like term anymore in it, so we are going to have to group them. All right, so don't forget the 3v. It's going to be part of my answer, but I just want to leave it alone for a sec, and I kind of want to ignore it and not think about it for a minute. What's the greatest common factor I can pull out of 3v cubed and 4v squared? It would be just v squared. And so what it would leave on the inside is 3v and plus 4. Okay, now I only want to look at my second set of parentheses. Remember, if your first term is negative, you have to pull out a negative. If not, it will be wrong. The other thing you can divide out from both of these is a 2. So that would leave 3v and plus, because negative times positive is what gives us that negative 8, 4. All right, let's check to be sure what's inside our parentheses are the same. It is. So our final answer, now I'm going to attach the 3v back on. So 3v stays on the outside. Our first set of parentheses is 3v plus 4. And our second set of parentheses were the GCFs that we pulled out. So v squared and minus 2. All right, and then number 24, it says the area is a square. So that should give you a hint that we're talking about perfect squares. Okay, think about it that way, perfect square roots. So what is the length of one side of the painting? All right, so the first thing is 81's perfect square is 9. P's perfect square root is P. So I want to put a 9P at the fronts because I know that 9 times 9 is going to give us that 81. I know at the ends it's a square root. Square root of 25 is 5, so it's 5 and 5, and it's adding. So I'm guessing this is correct, but let's double check. I need the insides and outsides when you FOIL it to equal 90. So 9p times 5 is 45p. Insides 9p times 5 is 45p. 45p plus 45p is 90p. So this is right. It's actually a better way to write it if it's the exact same binomial, to just write it once and put a squared by it. But again, if you leave it like this, it will be correct. Hey, before I turn this off, I'm just realizing I actually want to redo number 20. I didn't realize that at the very beginning I should have pulled out some H's. So I am so sorry, I apologize. Can you guys do me a favor and find a little spot to write down number 20 again? And I'm gonna fix it, because otherwise it's gonna drive me crazy and I don't wanna create a whole new video for one question. So it was, again, 7h to the 4th minus 4h cubed plus 28h squared minus 16h. As I looked back over that, I thought that doesn't look quite simplified, and it's not, because there's a lot more I could have done. So the first thing I'm going to do is I can't pull anything out of a 7 or a 4 because they're prime. But I can pull out 1h from all 4 terms. So that's what I want to do first. So if I pull out one of the h's, it will leave 7h cubed minus 4h squared plus 28h minus 16, and now I can group it. So now I can go in. Actually, it's probably good that I messed this one up because now you're just going to get more practice doing this again. And now I can group each of these. So h is going to be part of the answer, but I'm not going to worry about it for right now. I'm going to come back to it and add it on my answer. What can I pull out of 7h cubed and minus 4h squared? Only 2 h's. Okay, and that's going to leave 7h and minus 4. All right, what can we pull out of, don't look at this side now, what can we pull out of 28h and minus 16? I think the biggest thing is, we can pull out a 4. Let's try 4. So 4, and that would leave 7h minus 4. All right, let's check. This is much better. So I have the same answer here. So now I'm going to not forget my h. It's going to come back and stick itself on the answer. So we've got an h out front, and then our 2 sets of parentheses are 7h minus 4, since those were the ones that were alike, and the GCFs we pulled out, which is h squared plus 4. All right, this is a much better answer than whatever I had on 20. Yeah, this one, because I was like, I can still factor out an h on both of those, so why did that not work out? Okay, so I'm so sorry about number 20 originally, but this is the correct answer on 20.